Recently, there has been a series of events that force seismologists around the world to lean over their instruments with alarm. And we're not talking about some exotic corners of the Pacific Ocean or distant mountain ranges. Events are unfolding in the very heart of the civilized world. In Spain, an earthquake unexpectedly occurred that no one expected. And a week later, on July 20, at the opposite end of the planet on distant Kamchatka, the Earth shuddered with such force that local volcanoes began showing signs of life. Two events separated by thousands of kilometers but connected by one frightening pattern. Tectonic plates behave as if someone pressed the fast-forward button. And most frightening is that this is not chaotic activity but a clear pattern that indicates the beginning of a new cycle of planetary cataclysms. Why do scientists talk about a high probability of tsunamis in the Mediterranean Sea? What do 5-point tremors in Spain and a 7-point earthquake in Kamchatka have in common? And most importantly, are these events harbingers of something much more large-scale? On the morning of July 14, 2025, residents of a sunny European town woke up not to bird songs or the sound of surf, but to their houses beginning to shake like houses of cards. At 7:13 local time, the ground under Spain's southern coast shuddered with a magnitude of 5.2, powerful enough to make chandeliers in houses sway and tiles to fall from the ceiling onto the heads of unsuspecting passengers at the airport. The earthquake epicenter was located only 55 kilometers from the city of Almeria with its almost 200,000 population. The focus lay at a critically shallow depth of only 2 kilometers. This meant one thing. The energy of the underground strike was transmitted to the surface with almost no losses, making more than 50 cities from Granada to Alicante shudder. A week before this, tremors were already being recorded in the same region, first with magnitude 2.5, then 3.2. The Earth seemed to be warming up before the main strike. The fact is that the Iberian Peninsula is located in one of the most tense places on the planet at the border of two giant tectonic plates. The African plate inexorably presses on the Eurasian one at a speed of several centimeters per year, creating colossal tension in the Earth's crust. Spain itself is located on the so-called Iberian microplate, which is literally squeezed between these two titans. The Azores-Gibraltar-Tunisia fault runs precisely through southern Spain, turning the region into a zone of constant seismic threat. In March 1954, an earthquake with magnitude 7.9 shook southern Spain, causing significant damage in Malaga, Madrid, Granada, and Cadiz. And in 2011, the city of Lorca experienced a real nightmare. A series of earthquakes with force up to 5.1 points. Italy also doesn't stay aside from this seismic drama. In Naples, the most powerful earthquake in 40 years occurred with magnitude 4.6. But if you think Spain and Italy seem like distant and exotic places for earthquakes, then prepare for a real shock. In the very heart of Europe, in Austria, on February 1, an earthquake with magnitude 4.5 occurred that woke residents with powerful rumbling. And NASA and European scientists' research discovered an active seismic zone that begins in German Eifel and covers Belgium, Netherlands, France, and Luxembourg. Obviously, something is brewing in the very heart of northwestern Europe. Researchers stated discovering dome-shaped movements of the Earth's crust, indicating the rise of hot molten rock to the surface. But let's return to Spain. To understand why this beautiful country is turning into a seismically dangerous territory, we need to look deep underground, where a real geological revolution is unfolding. Under the bottom of the Mediterranean Sea, an entire tectonic plate literally turned upside down. Researchers from the University of Science and Technology of China discovered that the Alboran Plate, a piece of Earth's crust under the sea between Spain and Morocco, once rapidly plunged under Earth's mantle and flipped over. Water that was previously on this plate's surface is now underneath it, creating a low-velocity layer through which seismic waves pass like through jelly. It is precisely this upside-down world underground that explains one of the strangest features of Spanish seismology: deep earthquakes. In 2010, under Granada, a tremor with magnitude 6.3 occurred at a depth of 616 kilometers. This is twice deeper than earthquake foci usually lie and 10 times deeper than the recent tremor near Almeria. At such depth, energy should have dissipated, but it reached the surface with almost no losses. But if modern 5-point earthquakes now seem like a serious threat to us, historical memory preserves much more terrible events. November 1, 1755 All Saints' Day became the day that changed the course of European history. At 9:40 a.m., when Lisbon's churches were full of worshippers, the earth shuddered with magnitude 8.5, but the most terrible thing began half an hour after the main shock. From the ocean, a 16 m high tsunami crashed onto destroyed Lisbon. In a few minutes, the wave wiped one of Europe's richest cities off the face of the earth. Only in Lisbon, 60,000 people died. In neighboring cities, another 8,000. Modern seismologists warned this could repeat. A fault in the Alboran Sea could spawn a tsunami that would reach resort towns in a matter of minutes. Building codes in Spain were tightened after each catastrophe. Since 2007, it has been forbidden to build houses from adobe bricks and other fragile materials. They were precisely the cause of many victims in Lorca in 2011. But old buildings constructed centuries ago remain extremely vulnerable. In the historic centers of Granada and Seville, houses still stand that could collapse from a 4-point tremor. But there is good news. Overall, seismic activity on the Iberian Peninsula remains low compared to Turkey or Japan. The African plate presses on Europe at a speed of only a few millimeters per year. This is 10 times slower than plate movement in Turkey. Therefore, catastrophic earthquakes in Spain happen once per century, not every 10 years. Nevertheless, Spanish geologists are sounding the alarm. Since 1954, when the last truly destructive earthquake occurred, 70 years have already passed, and statistics speak of 100-year cyclicity. This means the next big strike could happen in the coming decades. While European seismologists studied underground processes in Europe at the other end of the planet, a dangerous picture of a completely different scale was unfolding. On July 20, the Kamchatka Peninsula experienced a series of earthquakes that made not only the earth shudder, but also the souls of thousands of people. The first signs of approaching catastrophe appeared at 18:02 local time. A tremor of magnitude 5.3 140 kilometers from Petropavlovsk, Kamchatka, but this was only a warning. A foreshock, as seismologists call it. 26 minutes later followed a more serious strike with magnitude 6.7, already enough for people to feel panic. And another 20 minutes later at 18:48 the main event occurred, an earthquake with magnitude 7.6 that turned an ordinary evening into a nightmare. The earthquake focus lay at a depth of about 50 kilometers, deep enough for energy to partially dissipate on its way to the surface, but not so much that residents of the peninsula didn't feel it. In Petropavlovsk-Kamchatka, intensity reached 7 points. This is already a serious indicator capable of damaging buildings and frightening people to the point of fainting. But nature hadn't finished its performance yet. The main shock was followed by an entire series of aftershocks. The earth literally convulsed like a patient in fever, not giving people a minute's rest. The scale of what was happening became clear when reports of consequences began arriving, but the psychological impact was colossal. Here, another formidable force of nature entered the scene: the ocean. Earthquakes of such magnitude can generate tsunamis, those very killer waves that turn the sea surface into an instrument of mass destruction. And the Ministry of Emergency Situations officially announced a tsunami threat for the coast of Kamchatka and the northern Kurils. Sirens wailed all along the coast. People were recommended to immediately leave coastal zones and climb to high ground. Fortunately, this time the ocean had mercy on people. The time for the first wave's approach passed, but the tsunami never appeared. Perhaps features of the bottom relief or the earthquake mechanism itself didn't contribute to the formation of dangerous waves. Meanwhile, underground, its own drama continued. Aftershocks followed one after another. In the first 48 hours alone, more than 400 were registered. Every 20 minutes, the earth began shaking again, not letting people relax. And then something completely unexpected happened. Avichinski volcano, which had been calm all day, suddenly reacted to the earthquake. Right after the series of tremors, it produced a steam gas emission 200 meters high above the crater. Specialists from the Institute of Volcanology and Seismology immediately understood this was no coincidence. The volcano's reaction to earthquakes became a vivid demonstration of how closely various geological processes are connected. Avachinsky is one of the volcanoes closest to Petropavlovsk-Kamchatsky, only 25 kilometers from the city. Its regular cone, 2,741 m high, is visible from practically any point in Kamchatka's capital. And when such a giant shows signs of life, it cannot but worry. A steam gas emission is not an eruption, but a signal that the magmatic system is activating. Historical experience shows that powerful earthquakes can indeed provoke volcanic eruptions. A classic example is the eruption of Galunggung volcano in Indonesia in 1822, which was preceded by a series of strong underground tremors, or a case closer to us in time, the eruption of an Icelandic volcano with an unpronounceable blank name that, in 2010, paralyzed air communication over Europe for several weeks. But let's return to the events of July 20. While volcanologists analyzed Avachinsky's behavior, an aftershock process of unprecedented scale continued underground. Aftershocks are not just residual oscillations as it might seem. This is a complex process of restructuring the stressed state of the Earth's crust after the main rupture. In the first 2 days after the main event, seismographs registered more than 400 aftershocks of various magnitudes. On the morning of July 21, another earthquake with magnitude 5.8 with a focus at a depth of 58.4 kilometers occurred 150 kilometers from Petropavlovsk-Kamchatsky. For many residents, this was the last straw. Nerves could no longer withstand constant tension. Head of the Seismic Monitoring Laboratory Vadim Saltykov explains, "Such an earthquake is not unique, although it is a rather rare phenomenon. Similar seismic events occur in Kamchatka approximately once every 10 years. The last earthquake of similar strength happened here in 1971, but then the epicenter was much closer to populated areas, which led to more serious consequences." Interestingly, the powerful earthquake of July 20 was preceded by foreshocks, weaker tremors that seemed to prepare the ground for the main event. First, less than an hour before the main strike, an earthquake with magnitude 5 occurred, and 20 minutes later, another strong tremor. This is precisely where the danger lies, that even a strong earthquake can turn out to be a foreshock of an even stronger one. But fortunately, analysis of aftershock behavior showed that the 7-point earthquake was indeed the main event, not a prelude to an even more powerful strike. But seismologists don't exclude the possibility of new noticeable tremors in the coming days and weeks. The earthquake mechanism fully corresponded to the geomechanical situation in the region. This was a typical interplate earthquake in a subduction zone. Precisely those events that make Kamchatka one of the most seismically active places on the planet. To understand why Kamchatka turned into one of the most seismically active regions of the planet, we need to look at this territory through a geologist's eyes. This peninsula is located at a unique point where 3 tectonic plates converge: Pacific, Okhotsk, and North American. The main role is played by the subduction process, the diving of the heavy oceanic Pacific plate under the lighter continental Okhotsk plate. The speed of this process is about 8 centimeters per year, which by geological standards is incredibly fast. Over 1 million years, the plate plunges 80 kilometers, dragging seawater and sediments into the mantle depths. It is precisely this water that plays a key role in the Kamchatka seismic process. At a depth of 100-200 kilometers, under the influence of colossal pressure and temperature of about 1,000 degrees Celsius, water begins to separate from minerals, lowering the melting temperature of surrounding rocks. This is how magma is born, molten rock that feeds the peninsula's numerous volcanoes. But water affects not only volcanic activity. Hydrated minerals of the oceanic plate create zones of reduced strength in the Earth's crust, where ruptures and correspondingly earthquakes occur more easily. This explains why Kamchatka regularly experiences not only surface, but also deep earthquakes up to 700 kilometers below the surface. Earthquake statistics in Kamchatka are impressive and simultaneously frightening. Over the last 100 years, more than 50 earthquakes with magnitude above 7 points occurred here. This means that on average, once every 2 years, the peninsula experiences a serious seismic strike. Events on the scale of July 22,025 with magnitude 7.6 happen approximately once every 10 years. But the most terrible in Kamchatka's history remains the North Kuril tsunami of 1952. On November 5 at 4:58 a.m. local time, an earthquake with magnitude 9 occurred off the shores of southern Kamchatka, one of the strongest in human history. 15-20 minutes after the earthquake, the first tsunami wave 5-6 m high approached the shores of the Kuril Islands. It didn't bring great destruction. Many residents even ran out to look at the unusual phenomenon, but this was only reconnaissance. 20 minutes later appeared the second wave 10-12 m high, which swept away most buildings. And the third wave 18-20 m high finished the job, a wall of water the size of a 7-story building. According to official data declassified only after 40 years, the number of victims was 2,336 people. But Kamchatka local historians and journalists cite figures from 10 to 14,000. The true scale of the tragedy was long hidden in Soviet archives. Entire settlements were wiped off the face of the earth, and survivors told how the ocean turned into a raging cauldron, swallowing everything in its path. The events of 1952 became a turning point in the history of Kamchatka seismology, but Kamchatka prepares other surprises for humanity. The peninsula is one of the most volcanically active regions in the world. More than 300 volcanoes are located here, of which 68 are considered active. Many of them are capable of eruptions of planetary scale, capable of changing the climate of the entire Earth. If it was interesting, give this video a like and subscribe to the channel.